Hey everyone, and welcome. Today, we are diving into something really cool in the world of AI. How do we actually teach agents to get smarter over time? See, the goal isn't to build a perfect agent right out of the box. Instead, it's about giving them the tools to learn, to adapt, and to improve from their own experiences. So, let's get into it.
And that brings us to the big question, right? Can an AI agent actually learn from its failures in a meaningful way, kind of like we do? Or is it just stuck repeating the same mistakes over and over until the developer has to step in and fix it? Well, we're going to explore the techniques that make real, genuine learning possible.
Okay, so here's our game plan. We'll kick things off with the basics of how agents learn. Then we'll jump into some really clever techniques that don't need expensive retraining. After that, we'll get into the big decision. When should you fine-tune? We'll look at a toolkit of methods for that, and then we'll wrap it all up to help you build your own learning strategy.
All right, first things first. Before we can get into the nitty-gritty, we got to lay some groundwork. To really get a handle on all the different techniques, you need to understand that there are two fundamental paths an agent can take to get smarter.
So you're going to hear this term agentic learning. What do we mean by that? Well, this is it. It's not just about, feeding an AI a bunch of data. It's a dynamic, active process where an agent is out there interacting with its world, trying stuff, seeing what works, and using that feedback to get better. This is learning in action.
And this learning really happens in two main ways. On one side, you've got non-parametric learning. Think of this like giving the agent a growing library of experiences it can look back on. Its core brain doesn't change, but its knowledge base gets bigger and better. Then you've got parametric learning, which is more like sending the agent back to school. You are literally rewriting its internal code, its brain, to fundamentally change how it thinks.
Now, let's dive into those non-parametric methods first. These are the techniques that let an agent get smarter on the fly, without all the heavy lifting and cost of retraining the entire model from scratch.
The most straightforward approach here is something called exemplar learning. And it's just beautifully simple. When the agent does something right, you just save that whole successful interaction. The next time it faces a similar problem, you show it that winning example to nudge it in the right direction. It's kind of like building a greatest hits collection for the agent to study.
Okay, but what about learning from failure? This is where it gets really interesting. There's a fascinating technique called reflection. Here, after an agent fails, it's prompted to actually critique itself. It writes a little note about what went wrong and what it should do next time, and then it saves that note. In effect, the AI becomes its own coach.
So here's how that loop works, and it's pretty slick. The agent tries something. It logs whether it worked or not. If it fails, step 3, it generates that reflection. That reflection gets saved, and then, this is the key, on the very next try, that note is put right into the prompt, steering the model away from making the same mistake twice, all without ever changing its core program.
Okay, let's make this feel a little more real. Imagine an online shopping agent gets this prompt. It needs to find a super specific product, dairy-free apple flavor variety pack, and it has to be under $30. It's a classic agent task, but there are a bunch of different things it could easily get wrong.
And yeah, on its first go, it messes up. After a few clicks, it fails. Maybe it found a dairy-free product, but it was the wrong flavor. Or maybe it totally ignored the price. The specific reason doesn't matter as much as the result. Status, fail. And that's the trigger. This is where reflection kicks in.
Now, expel or experiential learning takes this whole idea one step further. Instead of just learning from a single failure on one specific task, Expel starts to look for patterns across lots of different experiences. It tries to create these general, high-level rules, like always double-check the price filter before clicking buy. It's about building real wisdom, not just fixing one-off mistakes.
And this isn't some static list of rules. It's a living thing. The agent can add brand new rules based on new experiences. It can agree with old rules that keep proving to be useful. It can even edit rules to make them more general, or just flat out remove rules that aren't helping anymore. It's like a constantly evolving strategy guide.
Okay, so let's switch gears and pivot to the other side of the coin, parametric learning, or as we usually call it, fine-tuning. This is when you decide, you know what? The agent needs to go back to school to fundamentally change how it works.
But this brings up the million-dollar question, doesn't it? When is it actually worth it? Fine-tuning takes a ton of time, a ton of high-quality data, and a ton of computing power. It's not a decision you make lightly, so you better have a really good reason to make that kind of investment.
So, fine-tuning becomes absolutely critical in a few key situations. If your agent needs to speak the language of doctors or lawyers, highly specialized jargon, you fine-tune. If every single response has to follow a super strict format or tone, you fine-tune. And maybe most importantly, if the agent is making API calls where a mistake could be disastrous, yeah, fine-tuning is what locks in that rock-solid reliability.
But a lot of the time, you should probably hold off. If you're still just trying things out in a rapid prototyping phase, the flexibility of the other methods is way better. And think about it. If the big base models from OpenAI or Google are getting better every few months, your carefully fine-tuned model could be obsolete in no time. Plus, sometimes just getting really good at prompt engineering can get you 90% of the way there for a tiny fraction of the cost. And even within fine-tuning, you have this big choice: model size. On one hand, you've got a monster model like GPT-4o, which offers just incredible power, but man, it is expensive to run and tune. On the other hand, you've got these smaller, often open-source models that are way more efficient, and you'd be surprised, they can often match the performance of the giants on very specific, narrow tasks.
Okay, so you've weighed the pros and cons, and you're going for it. You're going to fine-tune. What's in your toolbox? Let's break down the main methods you can use to actually rewrite your model's brain.
Here are 4 of the big ones. Supervised fine-tuning, or SFT, is the classic. You just show the model a prompt and then the exact perfect response you want. Vision fine-tuning is the same idea, but for images. DPO is a bit different. You show it a good response and a bad one and teach it to prefer the good one. And finally, RFT is for really complex stuff, where you have human experts score the model's answers to teach it what high-quality reasoning looks like. Let's make DPO super clear, because it's a powerful one. Look at this. For the same user problem, you show the model 2 options. The chosen response on the left is helpful, professional, clear. The rejected one on the right is, well, it's lazy and unhelpful. By training the model on thousands of these pairs, it doesn't just memorize answers. It starts to internalize the qualities of a good response. Things like tone, clarity, and just being helpful.
All right, let's pull all these threads together. Now that we've seen the whole toolkit, how do you actually build a smart strategy? How do you pick the right tool for your specific job?
You know, in the end, it really just comes down to matching the tool to your goal. If you need your agent to be fast, agile, and learn on the cheap, you're going to want to stick with those non-parametric methods like reflection. If you need absolute, non-negotiable precision for something like an API call, then supervised fine-tuning is your best friend. And if your main goal is to just nail a very specific, nuanced tone and style, DPO is the perfect tool for the job.
So I'll leave you with this question to think about. When your agent, and it will, makes a mistake, what role are you going to play? Are you going to be its librarian, carefully collecting a library of perfect examples? Are you going to be its coach, teaching it how to reflect on its own failures? Or are you going to be its teacher and go back to basics by fine-tuning its core understanding? The choice you make is what will ultimately define how your agent grows from simple experience into true expertise. Thanks for tuning in.